Right, in this lesson, we are going to learn about change in momentum. We are just going to concentrate on the change in momentum. Remember, in our previous lesson, we learned about momentum. We said that momentum is equal to mass of an object in kilograms times velocity of the object in meters per second. Remember that. Okay, so in this lesson, we're just concentrating in the change in momentum. When objects collide with other objects, their momentum is likely to change. Remember, momentum is a vector quantity. Therefore, always choose positive direction before doing your calculations. Change in momentum formula is as follows. Delta P here meaning change in momentum. This delta means is for the change. Change in momentum is equal to the final momentum minus the initial momentum. Please remember this. This is the formula we use to find the change in momentum. Final momentum minus initial momentum. Remember, momentum is equal to mass times velocity. So we can replace this with this. See that it is the mass times the final velocity minus the mass times the initial velocity. Or you can factor out m here. You see these are two terms with m is the factor, so we can factor it out, and then we have our formula like that. So it's your choice. You can use this, but most of the times we use this. Okay, this is the formula for the change in momentum, where delta p is the change in momentum in kilograms meters per second, and then pf is the final momentum, again in kilograms meters per second, and then pi is the initial momentum in kilograms meters per second. So this is the formula we're going to be using. Right, we're going to explore different cases where change in momentum is experienced. I've brought these cases so that you can understand how we do calculations involving change in momentum. Let's look at the first case. Right, an object bouncing off another object. Now consider a 5 kg object, let's say a ball, with an initial velocity of 3 meters per second to the right, bouncing on a wall, and its velocity changing to 2 meters per second. So now, like this case, you see the ball will go towards the wall, then hits the wall, and then bounces back. Now we have the initial velocity, which is 3 meters per second, and then we have the final velocity, which is 2 meters per second. So here we can find what? Using this, we can find what? We can find our change in momentum. But remember, we have to choose our positive direction. Let's say to the right. This is option 1. Then option 2 will say to the left. Let's write our formula. Change in momentum is equal to final momentum minus initial momentum. Right, so we substitute this into our formula. So change in momentum is equal to the final momentum. You see, this one is going to the left, so it means it's going to be negative. So it's going to be 5. This is the mass in kilograms. Then velocity -2 because it's going in the opposite direction. And then the initial velocity, which is 3 meters per second. Still have 5 there, and then times 3 like that. Then what do you get? Change in momentum. You put this in the calculator. What do we get? We get -10 minus 15, which is -25 kilograms meters per second. So what does that mean? If the momentum is negative, it means it's actually in the opposite direction to our positive direction. So it means our change in momentum is 25 kilograms meters per second to the left. If we chose the left as our positive direction, we're going to get the same answer. Let me show you. Right, let's say now we chose the left as the positive direction. Our final velocity will be positive here. And then our initial velocity is what? Is negative. And then we get 10 plus 15, which is positive 25, showing us that this is the momentum in the positive direction. Right, let's look at the next case. In some cases, an object may collide with another object and stop when the velocity of an object is 0. So if the object has stopped, then its velocity is 0. So when the velocity of an object is 0, then the momentum is also 0. because remember momentum is the mass of the object times velocity of the object. And the object is said to be stationary or at rest. Let's look at this case. Consider a 5 kg object with an initial velocity of 3 meters per second, colliding with a net and stopping without bouncing back. Let's make our positive direction to be to the right. Right, positive direction to the right. Change in momentum is equal to final momentum minus initial momentum. So our final momentum in this case is 0. The object is stopped. And then our initial velocity is 3 meters per second. So this one is positive, 0 is 0, so it's fine. Mass times the final velocity minus the mass times the initial velocity. So the answer here is negative 15 kilograms meters per second. So what does that tell us? If it's negative, it means actually in the opposite direction to our positive direction. So it means actually 15 kilograms meters per second to the left. But if we chose the left direction as our positive direction, we're going to get the same answer. Let me show you. If our positive direction is to the left, then this is going to be negative. Then 0 will be 0 there. So our initial velocity, we put negative 3 in the formula, then becomes negative 5 times negative 3, which is positive 15. Since the answer is positive, then the momentum is in our positive direction. Alright, case 3. In some cases, an object may continue in the same direction after colliding with the other object. But now, slowly. It continues in the same direction, but it has slowed down. For example, if a ball rolls on a frictionless surface, it collides with a small pebble, but continues in the same direction, but more slowly. So what will happen? Let's say we have this situation here. We have our final velocity and then our initial velocity. Do you see that the final velocity is less than the initial velocity? Okay, let's choose our positive direction. Let's say to the right. So it means this one is positive, this one is positive, because they are both to the right. So our formula, change in momentum is final momentum minus initial momentum. So it's going to be change in momentum is equal to mass, which is 5 kilograms, and then 2 meters per second is our velocity there, minus mass, which is 5 kilograms, then initial velocity, which is 3. Okay, right, and then what do you get? 10 minus 15, which is negative 5 kilograms meters per second. Do you see you're getting a negative answer? So if the final velocity is less than the initial velocity, then you're going to get a negative answer here. Therefore, our momentum will be 5 kilograms meters per second to what? To the left. Please take note. The momentum remains in the same direction, but the change in momentum is in the opposite, since the magnitude of the initial momentum is greater than the magnitude of the final momentum. That's why the change in momentum is in the opposite direction. If our positive direction was to the left, we're going to get the same answer. Let's say to the left now, this one becomes negative, this one becomes negative because it's going to the left. Final momentum, 5 times negative 2, initial momentum 5 times negative 3. Then this gives us positive momentum, meaning that the momentum is in our positive direction. So still, we're getting the same answer. In case number 4, in some cases, an object may continue in the same direction after colliding with the other object, similar to the one we just did. But now, in this case, let's say the velocity of the object increases. For example, if a ball rolls on a frictionless surface, the other player kicks it and continues in the same direction but faster. Now, the final velocity is greater than the initial velocity. Right, let's choose our direction. Let's say to the right. Change in momentum is equal to final momentum minus initial momentum. Right, this is our final momentum. This will be positive. This will be positive because they're going to the right. Change in momentum is going to be mass times velocity, which is 4 meters per second, minus the mass times 3 meters per second. Right now we have 20 minus 15. So it means change in momentum is going to be 5 kilograms meters per second to the right. Let's say we'd used to the left as our positive direction. This one is going to be negative, this one negative. The initial velocity negative here, the final velocity negative here. And then we're getting negative 20 plus 15, which is negative 5 kilograms meters per second, meaning that our momentum is opposite our positive direction. Now it's going to be 5 kilograms meters per second to the right. So we're always getting the same answer. We may choose any direction, but at the end, we'll get the same answer.